How's it going, everybody? So this particular um, problem, we want to take a look at percent yield and percent error that might have in a reaction. So in lab, you'll be looking at different reagents when we're mixing them together, and you're going to see different products being produced. There's different types of reactions. You know, your single replacement. We've got decomposition, synthesis. So this applies for any type of reaction. This is just a particular one that I've picked. You should recognize this problem from a previous video. If you haven't watched the previous video on mass-mass relationship basics, you should watch that one first, because I'm going to make references to that particular uh, lesson and that particular reaction. So we've already done we already did all the stoichiometry, the basic stoichiometry for this reaction in that last lesson video. So I'm going to make references to that, so I'm not going to necessarily do all the work. So if you feel like or if you haven't watched that or feel like you need to rewatch that, go ahead and do so. I'll pause this video real quick, and you can just stop right here and then come back later and revisit this. Alright, if you're here, I'm going to assume you're ready to move forward. So, oops. So, okay, so from the previous time, we knew we had calcium hydroxide, and I have the 2 this time. And we had some hydrochloric acid, it was aqueous solution, and some calcium chloride was produced. It was basically in salt water, so it was also aqueous, right? It's in the liquid phase. And remember, we had to put a 2 here because we don't get 4 of those, right? 2 chlorines, 2 chlorines, and then by putting a 2 here gives us a total of 4 hydrogens on that side as well, right? And the 2 oxygens, everything was balanced. And in this problem, we had 4 grams of this particular reagent. We had calculated, so I'm going to put that in a different color. We had calculated, if I remember correctly, yep, we had calculated 5.99 grams of this substance here, and we had calculated the 1.95 grams of water. Okay, so this problem, knowing that, oh, I'm sorry, we've got that part. Results show that 5.63 grams of salt is the yield. So that means is produced. So what we need to realize is this value here is our theoretical yield, which is the same as saying your expected yield. Okay, your expected yield. That is a C, I promise you. Our expected yield. So that means that this right here, this value right here, it's saying that the results are showing this. So we know that this right here is what has actually happened in the reaction. So we have to define this as our actual yield, which is also sometimes referred to as the experimental yield. And so don't let those terms confuse you. So it's easy to sort of think about this. You can do all of this math. You can do all these calculations without ever lifting a finger, a piece of glassware, measuring out anything, etc., etc., etc. And you can theoretically calculate how much you should make. That's what this 5.99 is theoretically we figured out, hey, if we mix all this stuff together and nothing goes wrong, we'll make 5.99 grams of this salt in aqueous form. In this situation here, what's being said is you actually went back there, you actually did something, you mixed everything together, you did everything, blah, 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 you did all the good stuff, and when you're done, you've got 5.63 grams. So when you were experimenting, you actually did this. And then in this particular situation, this is the 5.63 grams. So with that said, you should remember, and if you don't remember, it's on your equation reference sheet, right? It's on your reference sheet. So basically, percent yield, and if you're talking about a percentage, you always have to have a ratio, which means you have to have a fraction. So that means any fraction, the bottom number, the bottom value is always the total amount of whatever it is that you're talking about, and then the top represents that portion, that ratio of the whole, right? So percent yield is obviously going to have to be some portion over the total. Well, in this case here, how we know we have a theoretical that we expect to get. So our percent yield is how much did we actually get versus what we expect to get, which is yield. And anytime you have a fraction, the only way to get a percentage is you have to multiply by 100. Okay. So that's the same right here, saying experimental yield over theoretical yield, same thing. So here we have 5.63 grams divided by our 5.99 grams times 100. You should see that like units cancel out. Very important. So calculator. So we've got 5.63 divided by 5.99, and then we're going to multiply that by 100. Just moves the decimal 2 places to the right. That gives us, let's see, we've got 93.98998. There's some other numbers there. At this point, we don't need that. And of course, that's a percentage. And so we had 3 significant digits here. We could go with 3 significant digits right here, which would, so 1, 2, 3 would make this, 8 would round that up. So we could say effectively, say 94%. Okay, so it's approximately 94%. If we want to be more precise, we could think of this as 4.000. That would be 4 significant digits, and we would go 93.99, and that would probably be a more precise answer, right? Okay, so now let's sort of split this right here. So that is percent yield. Percent error, if you look on your reference sheet as well, so percent error, so again, when you've got a percentage, that means you've got a fraction. So on the bottom has to be the total, the top has to be that portion that you're looking at of the whole, and of course times 100, right? So obviously the bottom is going to be the expected, right? What you expect to happen. Of course, it's going to have to be times 100. And then essentially what we're looking at is our actual minus the expected. That's the same as saying the experimental minus the theoretical. Remember, it's the same thing. And you're taking the absolute value of it. And the reason why is because you don't have a negative percent. A percentage is a fraction of a value, so it's referring to magnitude. So if we were to have a negative value, we're saying in this case, since we're working with mass, if we didn't use the absolute value symbols, then we would have a possibility of getting negative percentage signs, which means we have negative mass, and you technically can't have negative mass. Now you can have, if you think of a number line with 0 in the middle, and you think of the range of those values, you can have the same amount on either side of the 0. You could have 2 on this side or 2 on this side, or 4 on this side and 4 on this side. Remember, in either direction, remember when you think about it, to your right is always, you think of that as positive, and to your left you think of that as negative, right? And up is positive and down is negative, etc. So that's why we just don't have the negative value. So what we want to do is now it's just a matter of plugging and chugging. It's a basic algebraic algorithm. I mean, it doesn't get much simpler than this, other than this right here. All right, and algorithm, that's probably too strong of a word for something as simple as a basic equation. But that's all it is. It's a step-by-step procedure. So in this case, our actual yield, remember, was the 5.63. So that's 5.63 grams, measure the unit, minus our expected, that's 5.99 grams, and of course that's all in our absolute value. And then that's divided by, again, what we expected, which is 5.99 grams, and of course that's times 100. You should see that it is possible for us to subtract these two numbers because you can add and subtract like units. You can add and subtract 6x and 4x. You could say 6x plus 4x, or you go 6x minus 4x. But you could not go 6x minus 4y and get 2 something, because those are two different variables. So when we're looking at this right here, the grams unit is the same as a variable. So it's a unit of measurement. And so you should see that we would wind up with grams on top, and grams on once we finish subtracting these two numbers and get a difference. All right, so we've got 5.99 minus 5.63. We just want the difference of the two. That's 0.36, right? So that's 0.36 grams. The absolute value is gone because all we do is take the difference of the two numbers. 5.99 grams. Of course, that's times 100. And once again, like units over top and bottom, cancel out. It's all about canceling those units. It is always about canceling those units. So we got 0.36 divided by 5.99 gives us, and then times 100, right, that gives us 6.0100167, and of course that's percent. So now that really gives us 6.01%. Okay, so let's think about this number in reference to this number. Okay? If you made 94% of what you're supposed to, then it makes sense that you have 6% error, because 6% of what should be here is not here, it's over here in your error. Now let's go back to our original number here. You see how we have 3 significant digits here, 6.01? That 1, it's important. I mean, the two numbers we have after the 1 are these two zeros, right? So this is a really good situation where we realize that evaluating our answer is important. It's not just mindless plugging and chugging. We reported this over here, 94.0, because it followed the 3 significant digits. But right here where we have 6.01, this is important. That 1, it has value, it has some importance. So over here we realize that it's the best answer for this one is to take this 8, round this up. I'm sorry. Take this 9 and round that 8 up, and that gives us 93.99. Now if you think about it, we take 93.99 and we add in our 6.01. There's 10, carry the 1. We're doing elementary math here. There's 10, carry the 1, 9, 10, 10. We got our 100%. Everything works itself out. So this is a situation where you would need to go back and realize that the best way to report your answer is 93.99, not 94.0. And now your numbers work out perfectly, because everything is about the law of conservation of mass. Everything is about an equation. And on an equation, everything equals everything else on both sides. So you cannot just mindlessly go through the problem thinking, oh, this has 3 sig figs, so I'll just always use 3 sig figs. Sometimes you have 3, and when you're done, you need 4. You might need 5. And you'll just need to go back and remember your lessons that if you need to add significant digits, you just add zeros to your original numbers, and it doesn't change the value. It just gives you more numbers to work with so you can get more precision with your calculations to reflect the accuracy of the investigation. Okay, so hopefully that helped. Use this. Keep that in mind with what we've talked about, and keep in mind that error can be more or less one way or the other. So I'll leave you with one very easy example about that, okay? One very easy example. It's not even chemistry related, but it works. Everybody likes cookies. Everybody likes cookies. Everybody. Most everybody. So let's just say you're following a recipe and it tells you you're supposed to make 3 dozen. Well, we know 3 dozen is 36 cookies. Okay, so let's just say hypothetically you make them and you make 34 cookies. I'm just making this up. So theoretically, all right, so this is your theoretical. If you follow the recipe correctly, then theoretically you should make 36. But in all actuality, when you're done, you make 34 cookies. It was mostly good, but you obviously have some error because you didn't make 36. So what's your percent yield? Well, your actual amount, 34 cookies over 36 cookies times 100, cookies cancels out, right? So 34 divided by 36 times 100, 94.44, right? 90, did I do that right? Let me make sure. 34 divided, sometimes I punch numbers too quickly and I'll mess something up. About 36 equals that times 100. Yep, 94.4444444444. Right. 94.444%. Okay. So percent error. So actual minus expected. So 34 cookies minus 36 cookies. We want our absolute value, right? So that would be over the expected 36 cookies. You should see that the difference between 34 and 36 is, you guessed it, 2 cookies divided by 36 cookies. Cookies cancel out. It really does. So 2 divided by 36, all right, and then times 100, that gives us 5.5555, keeps going, and then there's a 6 like a mile down the road. I mean, like way down here in the calculator, there's a 6. All right, so you should be able to look at this and realize that sometimes 5s round up, sometimes they don't, but there might be an argument here that it does. If you look at this, 94 plus 5, 99. 0.4 plus 0.5, 0.9, that's 99.9. Grab this 0.4, that 0.5, 0.05, and 0.04 there, right? There's another 9. So now we've got 99.9. So we can make an argument as one of these 5s, we just round it up. We could make an argument that we just take this 5 and round this up right here, and that gives us 5.56% error. So that means we would look at this and go 94.44%. There's our 100%. It works, right? Oops. I'm on my Mac. If I'm not careful, I always hit that little. There's a feature where I can slide it over. I've got what's called hot corners, and so if I'm not careful, sometimes I put my cursor in a corner, and I've got it set up to slide all my stuff out of the way. So sorry about that. I'm not going to redo the video just for that. I still got Star Trek sitting in the background. So now here's something I would like you to really grasp and understand. Let's say the next time you do this, so all right, here's scenario 2. I'm going to split this over. Okay. Here's scenario 2. The next time you do this, you make 38 cookies. So now your actual, it's not 34, it's 38. Now you're going, wow, this is a win-win. I got 2 more cookies than I'm supposed to have and 4 more than last time. This is a win-win situation. But if you think about it, you still have error because you're only supposed to make 36. Law of conservation of mass. I don't care if you're talking about stuff in a chemistry class or you're talking about baking cookies with grandma in the kitchen. If you start off with 2 cups of flour, you can't make more than 2 cups of flour's worth of cookies. Not if you do it correctly. All right? So let's think about this. So our percent yield. All right? So our percent yield, we've got, so we made 38 cookies divided by what we expected, which was 36. And of course, times 100. Cookies goes away. All right, let's see here. We've got 38 divided by 36. That gives us times 100, right? So that gives us, if you think about it, that gives us 105.5555555%. You should be able to immediately see that right here and right here are the exact same thing. They are the exact same thing. And the reason for that is because the difference between what you expected and what you actually have is the same here as it was in this initial scenario. The difference between what you made here was 2 cookies, what you expected to make. The difference here is still 2 cookies, but it's on the other side of your number line. So if you think about a number line, right? Think about a number line, and we think to our right positive, to our left negative. You got 0. If you have a magnitude over here of 5, you got a magnitude over here also of -5. And that's why they teach you absolute value, because the absolute value, the magnitude, is still 5. 5 in that direction, 5 in that direction. So if you think about it, the difference is 2. We still have the same magnitude of difference. It's just in the opposite direction. So now we have 105%. Now you can't make 105%, but we should see that that's making sense. So let's look at our error. Percent error. So we actually made 38 cookies minus what we expected, which was 36 cookies. Again, absolute value. Divided by 36 cookies times 100. All right, you should see that that is 2 cookies over 36 cookies times 100 cookies. They're gone. So 2 cookies over 36 cookies, it's the same there. You should see we get 5.555. It's the same thing. It's the exact same thing. Oops. You should see that the error, it's the same value, it's the same magnitude. So it doesn't matter. So this is why we don't use the negative symbol, because you don't have negative error. It's just that you have to look at the number and interpret it. So 2 people who are following the same recipe, the group that had 94.44% error and the group that had 105.55% yield, 94.44% yield and 105.55% yield, they both have the same error, but they made different mistakes. And so that's what they would have to do, is think, what did I do that got me 34 cookies this time, and what did I do that got me 38 cookies this time? So that's the same thing as what's going to happen with you in lab. When you're working on stuff in lab, you're going to have to think, where did we go wrong with our procedures? Did we mix too much of this, not enough of that, not enough of this and this? Did we heat it for too long? Did we not heat it enough? These are, did we not filter it properly? Whatever the case may be. Did we not wash the substance properly? Whatever you're doing. You have to think about all of these things. Keep all those things in mind. All right. So I'm hoping that helped. You should see, I just took a very simple, common, everyday kind of example, and we see that it works in the equation because it's just math, right? Hopefully this has helped. Go back and review all of this. It's a lot in one video, but with this you should be able to do any kind of percent error, percent yield stuff that we're doing. You just have to read it, interpret it, and figure out what exactly is being asked of you in the problem. What information do I have? What information do I need to get? And then just proceed from there. Okay? So hopefully this helped. Take care. Talk to you soon.